All right, 4.3, irrational numbers. And really this should be titled rational and irrational numbers because we're going to talk about both. Objectives. Students will be able to determine whether an expression that is the combination of two rational and irrational numbers is rational or irrational itself. Before we do that, we got to define some things. First thing up, rational numbers are numbers that can be written as a fraction of two integers. Irrational numbers is the exact same definition except for there would be a can't there. They can't be written as a fraction of two integers. We have some examples here, right? 1 or any fraction that represents 1 is obviously rational. Any integer is rational, even if it's negative, because it could just be written as a fraction of two integers. Any decimal that doesn't go on forever is definitely rational. And some decimals that do go on forever, as long as it's repeating, can be written as a fraction of two integers. In fact, anytime you see this repeating symbol, you can actually take whatever the top number is. This is a general rule here. You can take whatever the top number is, the number being repeated, and put it over 9, and it'll end up equaling, once you reduce it, you'll see what fraction it equals. Then there's, of course, some examples of irrational numbers. Pi is probably the most famous, right? Those decimals go on and on and on forever with no pattern. This is a number you'll see in kind of some more advanced mathematics, but that's another irrational number that just goes on and on forever. The square root of 2, or the square root of any number that's not a perfect square, is an irrational number, and so you'll get some weird decimals that go on and on forever. This is the golden ratio, and that the golden ratio also is an irrational number that just goes on and on and on forever. So those are just examples. Those are by no means the limit of all irrational numbers, but they're just some examples to help us kind of frame our mindset about these types of numbers. So example 1's down here says, which of the following real numbers are rational? Well, let's just take a look. Let's take a look at this first one. Are irrational. That's right. We're asking if they are irrational. So, is this irrational? Well, before they do that, I want to just try and simplify square root 8. Hopefully we know that square root 8 is the same thing as square root 4 times square root 2. And the square root of 4 is 2, and so we're just left with 2 rad 2. So we could write this as 2 square root 2 over 2, and the 2's would cancel out. And so this ends up actually just equaling the square root of 2. Okay. Well, we already know the square root of 2 is one of our irrationals, along with all other numbers that are square roots of not perfect squares. So yeah, that's irrational. Pi also is one of our numbers that we listed up there, so that's irrational. But 5 could be written as 5 over 1, or 5.0 is 5 over 1, so that's rational, therefore not irrational. 0.325, you could take the numbers after a decimal, and you could write them over 1 with as many digits as there are in zeros, and then you have a fraction. So 0.325 is the same thing as 325 over 1,000, and therefore that is rational, so that doesn't qualify. We said repeating numbers before. We said that repeating numbers, you can just take the number and put it over 9. So this is like saying 7 and 7/9. Well, if you wanted, you could put this as an improper fraction. We've done this in the past. 9 times 7 is 63, plus 7 is 70. So this ends up equaling 70 over 9, which of course makes it rational. So that doesn't qualify. And we can do the same thing with 8.5. 2 times 8 is 16, plus 1 is 17. So this is 17 over 2, which is rational and doesn't qualify. So the only two here were the first two. All right. Now we're going to get into some basic rules here. The first two rules are pretty simple. And you'll kind of recognize this just as you play with some of these expressions. But if you're adding, and when I say adding, that actually qualifies for adding or subtracting. So maybe I should even say like plus or minus, plus or minus, plus or minus. It's either of those are plus or minus. So rational plus irrational will always give you a rational number. So if you're adding or subtracting two rational numbers, it'll always be rational. So here's an example. Some fractions added together, they equal just another fraction. Or some fractions multiplied together, or rational numbers multiplied together, they're just going to equal a rational number. But if we add a rational to an irrational, right, like 3 plus pi, we get some new irrational number. Or a rational times an irrational, that's also going to be irrational. The only time when it gets a little tricky is when we have two irrationals either added and subtracted or multiplied. And by the way, right here, all these things I'm saying multiplying, but multiply is kind of in the same category as divide. So even though I'm just saying multiply here, remember that this rule is true for dividing as well. And let me just explain why real quick. Let's say I was dividing. I had A divided by B. Well, that is the same thing as A times 1 over B. So even though I'm dividing here, I could rewrite it as multiplying, and therefore dividing still counts as multiplying. Okay, so in this situation, if you're doing an irrational number plus another irrational number, it could be rational, like in this case. This is irrational, but it equals 1, which is rational. Or I could add these two irrationals together, and it just gives me another irrational number. Here, I'm multiplying two irrationals together. Square root 2 times square root 2, and that actually ends up being 2, so that's rational. But here's two irrationals multiplying together, and it's irrational. So for these ones, it just depends, and we have to always just check. We have to work it out and see, does it end up being rational or irrational? All right, let's go to the next page. So we got some examples of a couple problems here. An example 2, I want to work with you guys, and we'll see if it's rational or irrational. One of the first things I'm going to do is, I know my properties of square roots allows me to write this all as one big square root of just 27 over 3. And 27 divided by 3 is 9. So the square root of 9 is 3. So it turns out that this is actually rational. And like I said, we didn't know for certain just by looking at it because we have two irrational numbers being divided. And we don't know if that's going to be rational or irrational just by looking at it. We have to actually work it out. Over here, something similar, two irrational numbers being divided. We're going to find out, is it rational or irrational? So go ahead and give that one a try on your own. Pause the video when you're ready to check, and then when you're ready to check your work, unpause it, see how you did. All right, so 21 divided by 7 is 3. So I wrote it as one big square root, and then I simplified, and that's just simply square root 3. Square root 3 is irrational. So we got a situation here where both times we were dividing irrational numbers, and one gave us rational and one gave us irrational. So like I said, we just have to simplify those out each time. All right, so I want you to just take a minute for the summary, define rational and irrational numbers in your own words, put that into Edpuzzle for me, and I'll see you guys in the next video.